Oh, hi everybody. So today we're actually going to be talking about distance on a coordinate plane. So I'm going to use my coordinate plane right here. So all I have to do is I first have to draw my line. Okay, this might not work. Let's just go to the computer version. Midpoint and distance on a coordinate plane. So let's get started by reminding ourselves about coordinate planes. A coordinate plane is a plane that is divided into four regions by a horizontal line, or left to right line, called the x-axis, and a vertical up and down line called the y-axis. The location or coordinates of a point are given by an ordered pair, x and y. So in this case, it goes 3 to the right and 4 up, which means our point would be 3, 4. The x and y axes separate the coordinate plane into four regions, which are called quadrants, and which are numbered with Roman numerals placed counterclockwise. If you do not find that you naturally remember the Roman numerals, think of the Star Wars movies. 1, The Phantom Menace. 2, Attack of the Clones. 3, Revenge of the Sith. 4, the one that is now called A New Hope. So now let's talk about midpoint formula. You can find the midpoint, or the middle, of a segment by using the coordinates of its endpoints. The midpoint is the average of the x-coordinate and the average of the y-coordinates of the midpoint. So here is our midpoint formula. x1 plus x2 divided by 2, and y1 plus y2, meaning the y value on the first and second point, divided by 2. So let's try that in this case. In the case of the segment on the right, point 1, x1, y1, is at negative 2, 3. So let's add those to our formula. So instead of x1, it's going to say negative 2, and instead of y1, it's going to say negative 3. Now, point 2, x2, y2, is at 4, 5. So let's replace those. We now have negative 2 plus 4 and negative 3 plus 5. Negative 2 plus 4 is 2, and negative 3 plus 5 is also 2. So our point is really 2 over 2, 2 over 2, which simplifies to be 1, 1. Right there is the midpoint. Let's try an example problem. So in this case, we want to find the midpoint of negative 2, 5, and 6, negative 3. I'm going to put these up just so it's a little bit easier for us to see. All right, so I'm going to use my formula. So in this case, it is x1, which is negative 2, plus x2, which is 6, divided by 2. And then y1, 5, plus y2, negative 3. So I'm going to write minus 3, divided by 2. This ends up being 4 over 2 and 2 over 2, which makes our point be at 2, 1. And that's our midpoint. All right, let's try another one. In this case, our question is, S is the midpoint of RT. R has coordinates of 6, 1, and S, the midpoint, has coordinates of negative 1, 1. We need to find the coordinates of T. So in this case, we're going to say that the midpoint, or negative 1, 1, is equal to negative 6 plus x2 and negative 1 plus x2 over 2. All right. So in this case, we want to actually think of this as like two different equations. Negative 1 is equal to negative 6 plus x2 over 2, and 1 is equal to negative 1 plus x2 over 2. So I'm going to actually write those out. Negative 1 is equal to negative 6 plus x2 over 2. And this is not x2. Let me fix this. Plus y2. And then 1 is equal to negative 1 plus y2 over 2. In the case of both of these, we would multiply by 2. So negative 2 equals negative 6 plus x2, and 2 equals negative 1 plus y2. So we would add 6, which gets us 4, and then we would add 1, which gets us 3, meaning that would be our midpoint. And here we go. 4, 3 is not our midpoint, it's our other endpoint, which is right here. And I know it looks right to me. So now let's talk about the distance formula. So the distance formula is used to calculate the distance between 2 points in a coordinate plane. The following is the distance formula. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, you can also write it like this because x2 minus x1 is also the change in x, and y2 minus y1, so x2 minus x1 is the change in x, which is this value, and y2 minus y1 is the change in y, which is this value. So let's try it out. Okay, so in this case, we have our 2 points, negative 2, negative 3, and 4, 5. So let's start out by putting in our x1 values. So x2 minus negative 2 squared and y2 minus negative 3. This is really plus 2 and plus 3, but we'll keep this for now. Now we want to substitute in our x2 and y2 for our second point. So this becomes 4 minus negative 2 and 5 minus negative 3. So when we combine like terms, 4 minus negative 2 is 6, and 5 minus negative 3 is 8. 6 squared is 36, and 8 squared is 64. 36 plus 64 means that the distance is equal to the square root of 100, which means our distance is 10. Now I want to quickly ask you, does the distance formula remind you of anything? So this is our distance formula, and I'm using the change in x and change in y because it makes it a little bit more clear. So distance is equal to the square root of the change of x squared plus the change of y squared. Now if I wanted to get where this square root wasn't there, I'd just square both sides. And I'd get distance squared equals the square root of x squared plus the square root of y squared. And this is starting to remind me of c squared equals a squared plus b squared, or a squared plus b squared equals c squared, which we call the Pythagorean theorem. So let's see if we can use the Pythagorean theorem for distance formula. So here's our formula, here's our picture from the before. In this case, I just want to choose the change in x. So the change in x in this case is going to be 6, and the change in y, or the vertical shift, is 8. Then we have 6 squared plus a squared. That's 36 plus 64. C squared is 100, and we'd square root both sides. C is 10. When you're given a distance question, you can choose to use either method if you have graphing paper or some other way of actually visualizing that out. All right, thank you all very much for watching. Please remember to like and subscribe, ring that bell for notifications, and all those other things. Feel free to comment as well. Just, destroy that algorithm. Thank you all very much.